Hi, welcome to EduHub Academia, the Education for a Better Future platform. We will continue the World of Physics course, lecture number 6, by talking about electromagnetism. Let's begin by defining electromagnetism. It is that branch of physics which describes or reveals the relationship between two forces, fundamental forces in nature, the electric and the magnetic force. Electricity can generate its own magnetic field, and vice versa, magnetism or magnets could generate their own electric fields. This is basically the concept of electromagnetism. We can illustrate that, we can understand that if we look at the picture, the animation picture here. You can see a copper solenoid of so many number of turns. It's a coil, but we call it solenoid. The green color represents an alternating current which keeps changing direction, as you can see here by the arrowheads, entering from one side and leaving the other side. Now, this alternating current will produce a magnetic field inside the solenoid. So the solenoid becomes like a bar magnet with two faces, one N, one S. Now that the solenoid is a piece of magnet, or acts as a piece of magnet, it will generate its own electric field that can be shown by a current flowing in the circular loop connected to the ammeter. The deflection of the ammeter indicates the presence of an electric current due to one simple reason, the current that is entering through the solenoid. This is basically the concept of electromagnetism. Now, in relation to electromagnetism, we have electromagnetic radiation. The first picture on the left shows us how the combination of electric field and magnetic field create electromagnetic wave, like light, for instance, like radio waves. All those are combination of two fields that propagates, as you can see here in blue and pink, from left to right with a certain frequency and a certain wavelength, and of course a certain speed, which is the speed of light. The electromagnetic spectrum on the right shows us a range of waves, starting with a radio wave with the highest wavelength but shorter frequency or smaller frequency. As we go to the right, we go through microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Gamma rays are the rays with the highest amount of energy. They have the smallest wavelength, yet because of the inverse proportionality, they will have the higher frequency, and because of their high frequency, their energy is very high. That's why gamma rays are radioactive, dangerous rays. Even X-rays are dangerous, but they are not as energetic as the gamma rays. So this is called electromagnetic spectrum, which is the result of an electromagnetic wave. Where can we find applications of electromagnetism in real life? We have so many numerous different applications. We will see some of them over here. The electric motor. The electric motor works on the principle of electromagnetism, where electrical energy is converted into mechanical and something will turn on. MRI imaging, electromagnetism resonance. Now here, this machine uses electromagnetism to really view inside the human body. Wireless communication, like mobile phones, radios, televisions. And finally, transformers. And you remember, transformers are those devices that can really change or step down or step up the voltage from high to low voltage or from low to high voltage to get the required or the needed voltage. Also, those devices, the principle of those devices depend on electromagnetism. Thank you for listening. I look forward to meeting you in the coming lecture.